In this video, we're looking at solving a simple trig equation. This problem says find all the values of x such that the cosine of x is equal to 0.7328 to the nearest whole degree. Okay, so I'll bring this down here so we have room to work. This is the cosine of x is equal to 0.7328. And to solve this equation means finding the angles that we could put into x so that the cosine of that angle would be equal to this number. And here's how we can do that. I'm going to take the inverse cosine of both sides of this equation. So on the left side we have the inverse cosine of the cosine of x, and on the right side we have the inverse cosine of 0.7328. Now the inverse cosine of a cosine, they undo each other, so we're left with just an x. That's the reason that we have inverse cosines, so that they can undo cosines. Is equal to, on this side we need to use the calculator. So I'm going to bring out the calculator, and I'm going to make sure my calculator is on degrees. Why? Because it says in the problem that we want the answer to the nearest whole degree. So make sure that your calculator is on degrees. So we're going to go to mode. And under mode, it gives us a choice of radians and degrees. This one is on degrees. And so we can back out of there, second quit. And now I'm going to use the inverse cosine. The inverse cosine of 0.7328. So second cosine gives me my inverse cosine of 0.7328, and we find that gives us 42. It says 42.87835558 rounded to the nearest whole degree. Since this is 42.8, I'm going to round it up to 43 whole degrees. So this is saying that x is equal to 43 degrees as one possibility, but that is not the only angle that works. Once you have found one angle, you need to draw a picture to find the others. I'm going to make a unit circle right here, and I'm going to estimate where is this 43 degrees. You do not have to be super accurate, you just have to estimate and get it in the correct quadrant. I estimate that 43 degrees is right about there. So this is an angle of 43 degrees, puts me right there. And we want to find what is the other angle. Are there any other angles that will have the exact same x value? The x value of this point right there, the x coordinate of that point? Well, the point that's down here has the exact same x coordinate, right? Because both of these pass through the x-axis at the same place. And so what that is that's the reflection of this angle through the x-axis. Remember, cosines depend upon the x values, and so to find solutions, to find solutions for cosines, we reflect angles we know through the x-axis. So we'll reflect this angle, this 43-degree angle, through the x-axis. And now we need to find what is the size of this larger angle here. Well, if this is 43 degrees, that must mean that this is 43 degrees below the x-axis, since this is a reflection, which means if we take the whole 360 and then back up 43, that'll give us the angle that we want. So to do that, what we're really doing is we're taking 360 and then we're subtracting the 43, and when we do that, we get 360 minus 43, that comes out to be 317 degrees here. Well, these are the only two angles that you can put in for x, and it'll give you this number as long as you stay between 0 and 360. But if you let yourself go around and around and around, you can land on other angles that are at those 2 points, this point and this point, and you'll also have the same value. So to get all of those coterminal angles, we add 360 times n. This n stands for the number of times you've gone around the circle. So plus 360 times n. For example, if we only go around the circle once, it's 43 degrees plus 360, which would be 43 degrees plus 360, and there I am back to where I started. If n is equal to 2, then we go 43 degrees, and then we go 360 once, 360 twice, and there I am back there in the circle. So you see n stands for the number of times we've gone around the circle, and so really we have found an infinite number of different solutions to this problem. And these are our final answers.